Here we. Good thing this is recorded. So we're here back at Devoxx, and I'm here with Ilya Grigorik, who's here talking about performance and Chrome DevTools and performance of front ends and web apps. So welcome.
Thank you.
You were covering two things. First of all, in the university session, how to make websites performant, and performance is kind of a black art, I think, to a lot of people. So, and browsers at the same time are pretty complex things. They're almost like an OS. So should people try to understand how it's built, or are there any low-hanging fruits or a methodology to get your things to...
So it's both, right? You should always go for the low-hanging fruit because by definition those are the low-hanging fruit. But I think in general, if you want to build an application that is performant over the long term, you need to understand how the mechanics of your operating system work. And you mentioned that the browsers are increasingly becoming like an operating system. They absolutely are, right? You have networking, you have graphics, you have everything in between, right? Like there's literally not a computer science problem that we're not like pushing boundaries on in a modern browser. That's not there. So that was in large part what the session was about. Of course, you can only fit so much into 3 hours, but nonetheless, it was like 3 hours of
still quite
like,
a bit.
Here's how the browser works.
Right, and people can find your slides online, and if they Google them, I'm sure
That's
we'll have a link somewhere so people can find them. I think they're very useful, even with us, and it will be on parlays as well for people to watch. How about things like page speed or using CDNs or DNS lookups is an obvious thing people don't always look into. These are all good things.
So these are all techniques, right? These are all, like, it's one component of a larger picture, right? So we kind of, in the web performance community, if you will, we kind of have this distinction, which I don't think is actually necessarily even fair, which is back-end versus front-end performance, which is like the stuff that happens on your server, and then everything that the browser does. Whereas I like to take kind of like a holistic picture and say like, well, the lifetime of a page or your app or what have you needs to take into account both, right? Because sometimes maybe your app is blocked on DNS, and then the question is, how do I find out? How do I measure it? I guess kind of the other meta point that I like to make about performance is a lot of people treat it as a technical metric. It should be a business metric. Performance is a feature. Like, there are products out there where speed is a feature. Think of Google search. Like, speed is a feature, absolutely, right? And you should design for it as such. So if you can connect speed and performance to your business or bottom line metrics, and in fact, I've shown a number of case studies from other companies outside of Google where they see a direct correlation between how fast the page loads and my conversions or bounce rates or and everything like that, right? If you can show that to your CEO, CFO, your team even, right? That's a viable metric as opposed to just being like, on a weekend, I'm going to spend my 20% time optimizing the page.
Well, and it's interesting to see how people actually start using Chrome DevTools as more like development tools, not just the afterthought, the tool you bring up and to fix performance after you've built it. So people are spending more time in tools such as the ones provided in Chrome.
Yeah, I think, so that was kind of my second talk, which is the whole premise is the browser is probably one of the most well-instrumented platforms that we have today. And you may just not realize it yet. That was kind of the tagline, right? And you can do all kinds of stuff. You can do detailed network debugging, look at the graphics pipeline, look at the low-level networking, and in fact you have to. Like, once you actually get into the weeds of like what is the browser doing, that's what you need to understand. And it is almost like an IDE at this point.
Yeah. True. I see a lot of people, a lot of developers actually using it as such. So you actually looked at the Devoxx website as well, and you have a few things to share with our friends organizing the conference and running this website. What kind of things did you find on? And are they typical of things you find?
So they were actually typical, and I have to say the Devoxx site actually was pretty good. All things considered, so no complaints there. But, so some interesting takeaways. An average page on the internet today is about 1 megabyte in size. 1 meg. I find this number surprising, right, the first time I heard it. And it's composed of over 80 requests. So one page, but there's 80 resources, images, JavaScript, CSS, that need to come in to compose the page. And we're connecting, on average, to over 30 servers. To fetch all of that data, right? And of course, as users, we expect all of this to happen instantaneously. It's like, yes, connect to 30 servers, compose all of this, and just like instantly display it. I think for Devoxx, if memory serves, it was more requests. It was like 140 requests. Yeah. But nonetheless, it was structured well, so it loaded pretty fast.
Okay.
So they did a good job.
Somebody must have been using Chrome tools.
Yes. Yeah.
Okay. Cool. So you also covered something about the difference between latency and bandwidth, and how developers should look at it. How it's really important.
Yeah. So this is a big aha moment, I think, for a lot of people, where you turn on your TV, you watch the commercials for your ISP, and it's like, get the latest 4G, highest speed, whatever bandwidth connection, right? And oftentimes, I think we think of speed and performance on the web as just bandwidth. Like, can I get a bigger pipe, if you will, to my house? Because that'll solve all problems. You know, if we have bigger pages, so what? We'll just get more bandwidth. The problem is bandwidth doesn't actually help after a certain point with web browsing. So as we said, we have 80 requests. We have many parallel connections. And if you kind of go into lower levels of how TCP works, we don't actually use all the bandwidth at the beginning of the TCP connection. So you're actually bound by latency. And unfortunately, latency is not changing. We have this annoying thing called the speed of light, and we just can't figure out how to go any faster. So because of that, we need to pay attention to latency. You mentioned CDNs. The whole point of a CDN is to get a server closer to the user, such that we can terminate the connection faster. That is the prime point there, right? And just understanding why you need that is very important. Okay. So, if you're running a site here in Europe, and your server is in, I don't know, US, because you're using some cloud provider, you're penalizing all of your users by a significant margin, like 150, 200 milliseconds.
Right. And eventually, you're not making as much money as
right,
you should
and in all likelihood, your bounce rates are higher and other things.
So speaking of all of this, how much of that is going into innovation and standards? I mean, I hear about HTTP2 maybe coming along. Can you say a word about that and how maybe that was inspired by
so actually
Google?
one of the efforts that we've been sponsoring at Google and working very closely with is the W3C Web Performance Group. So this is a group that was started a couple of years ago, and it has already created a number of standards like navigation timing. So navigation timing allows you to get instrumentation data out of the browser for things like, so how long did the DNS lookup take? Right. You couldn't access this data maybe even a year ago, right? So we have this now, and you mentioned HTTP2, so that was also in some part driven by Speedy. So this is a kind of experimental protocol we deployed at Google, and it's available in Chrome, Firefox, and Opera now. And
is it fair to say that it's used in most services? So if you're use a Chrome browser and access a Google service, it's actually...
So Google servers speak Speedy. Chrome speaks Speedy. So if you're accessing our service, so if you're reading Gmail or doing Google searches via HTTPS, you're running over Speedy. You're not running over HTTP.
Right.
Now, here's a caveat. Speedy is not a replacement for HTTP. Speedy is HTTP is still the same, but we kind of change one layer below, basically how we send the messages on the wire. Yep. And by virtue of changing that, we can actually make the transport more efficient. So we can push multiple resources over the same connection. So the HTTP 2.0 effort is basically that, or at least we have a charter now for that working group, the ITF working group, which is going to take Speedy version 2 of the protocol that we designed and use that as a starting point. So in the coming year or a couple of years, hopefully we'll standardize it and release it as HTTP 2.0.
Okay, great. That's exciting to hear.
And the world will be a better place.
Of course, that's what we all aim for. Let me close with a final question. What about mobile? In this whole picture, that's probably some place where performance is as important, if not more important, than desktops and typical browsers. You have also browsers there, and tools are actually available to help you with that. So what are we doing
So
here?
everything we've just talked about applies to mobile, especially bandwidth and latency. So of course, we still have room for improvement in terms of bandwidth on mobile. Okay. Having said that, latency is much worse than desktop for a number of reasons, which we won't get into here, but it only makes it more important that we design with efficiency in mind, like reusing connections, leveraging all of the caches, and all the rest. We also are building, I think, we are building, but we still need a lot better tools for mobile. So for example, in Chrome, we have remote debugging.
Yep.
And this is very important, not just because you can connect to your phone and kind of pull the data out of it, but you can actually simulate and use the wireless network on your phone to like feel how the page looks, or how it downloads, if you will, or even how it executes, right? Like, we develop our apps, mobile apps, on our desktop. We run it on an emulator, which is still running on your like beefy, whatever, quad core with whatever graphics card. Then you put it on your little phone, right? And it's still underpowered, comparatively speaking. Like these things are getting very good in terms of computing power and all the rest, but nonetheless, orders of magnitude less. And then it just feels very different. Right, so you can, with Chrome DevTools, you can now use all the same tooling to debug on your phone, which is awesome. I think we still have more room for improvement, though.
Okay, great. So looking forward to those improvements as well. Thanks for taking the time.
Thank you.